Section 2.6 is the last section in Chapter 2, and it deals with the notion of independence of two or more events. So here is the idea. When the probability of A given B is equal to the probability of A, one can conclude that the occurrence or non-occurrence of the event B has no effect on the probability that event A occurs. In this case, we say that the events A and B are called independent events. So let me put a little more detail into that. Let's say we're interested in the probability of event A occurring, given that the event B has occurred. By definition, this is the probability of A intersect B divided by the probability of B. And if it's the case that whether or not B occurs or not does not matter, if this happens to be equal to the probability of A, then what we would say is the two events are independent. Now, if you take the right-hand equality here and simply multiply both sides by P of B, you get the probability of A intersect B is equal to P of A times P of B. And that equation right there is the basis for the following definition. Events A and B are independent if and only if the probability of A intersect B is equal to the probability of A multiplied by the probability of B. Another way of saying that is if the occurrence or non-occurrence of one event doesn't affect the probability of another event occurring, then the two events are independent. Now, if two events are not independent, then they are considered dependent.